Okay, so let's take a look at this particular question here. It says, what can be predicted from the histogram comparing the mass of Macintosh apples? They must be trying to make a joke there. And the mass of Gravenstein apples. So first thing I need to make sure, all right, the heights are the same here. We've got the frequency. First thing I notice is that this graph right here has a kind of skinnier distribution curve, and this one has a wider distribution curve. So I might predict some questions about standard deviation, about spread. So, but I don't want to just make that assumption. So I need to look at these numbers right here. If I assume that the average is somewhere around here for the Macintosh apples, 125, and the average here is somewhere, let's say around 250 to 275, how far is the data spread? So I said that this probably has a smaller standard deviation by looking at it, but let's just check here. All the way out to the end here is 175, so that's a difference of about 50, and all the way to the end here is about a difference of 50 as well too. How about here, all the way to the end, from 250 to 325? That's a larger number than 50, the difference there, so maybe 75-ish, and then even at the other end of the spectrum, we have almost over a 100 gram difference. So I'm correct in assuming that the standard deviation here is smaller. So around the mean, sorry, and then over here around as well too. That's the only real thing that I can conclude. I could also conclude that the averages are definitely different as well too. So when I approach a question like this is what you should be doing. Try to come up with an answer before you read right here, because no matter what, a lot of these answers are going to be designed to try and mislead you and confuse you. So trying to formulate your own answer first is going to be a good first step here. So let's see. Now let's read the answers here. So the question, what can be predicted from the histogram comparing these two graphs of two different apple sources? So more fertilizer had been used to grow the Macintosh apples. Even if that were the case, which means that these apples might be bigger, first of all, they're not. And second of all, there's no way I'll have any idea if fertilizer has been used. So that's no, bad. B, the mass of Macintosh apples has a smaller standard deviation than the Gravenstein apples. That's what I was talking about. And according to this looks like it does make sense. So I like that. I'm not going to cross it out yet. And then, of course, keep on reading. C, the electronic balance used to obtain the data was only accurate to 5 grams. I don't have any information here about that. Maybe everything's rounded to 5, but that just means that somebody just rounded the masses to 5s in order to create these actual scales. So we don't know about, obviously, the electronic balance. They don't have any uncertainties here, like plus or minus 5 grams given as information in any kind of legend. So we can't assume that that's going to be correct. And then D here, it says the distribution of the two apple masses overlaps by 68%. Here, they're throwing out this number 68%. If you remember anything about standard deviation, then this percentage should be very famous to you. But what that means is if you have a distribution and the average is at this point, it means if you go plus or minus 1 standard deviation, then 68% of all the apples lie within 1 standard deviation of the mean. So in this case, we're not given the actual standard deviations, so we don't know how to actually compare these two. So this is an example where they're throwing these percentages out to really confuse you. And if you just barely remember that 68% was an important percentage, you might be led to pick that one because you're like, oh yeah, standard deviation, and then you end up picking that one. So watch out for that. But definitely here, the only thing that can be strongly concluded from the data based on these 4 answers here is that the standard deviation for the Macintosh apples is definitely smaller than for the Gravenstein apples. What does that mean? That means of all the apples that exist here for the Macintosh apples, they are closely, the largest and smallest sizes are more closely surrounding the mean than they are the Gravenstein apples. So I guess one more way to say that is a smaller standard deviation here means that the apple sizes are more closely clustered around the mean than they are compared to the Gravenstein apples. There's a wider spread. Less spread, wider spread. Smaller standard deviation, larger standard deviation. So B is the answer that we have to conclude. All right.